Did I miss you guys? Oh, man.
Everyone gets home, except for you guys. Just fail it.
Just because I missed you, I'll make sure you get pink. Vertical translation. Wow, how do you like the sound of that? Hey, what does vertical mean?
Up and down.
Up and down.
Up and down. Okay. And what does translate mean?
All around.
That would be nice because that rhymes, but what does translate mean?
You take the same line or same triangle and you move it.
Some of you.
Translate it across the section.
Okay, some of you know in terms of math, we're going to be moving a shape. Okay, and if you are translating a language, you maybe have one thing that means something in this language, and you got to find the link to get to the same meaning in a different language. All right, so Isabella has some practice or somewhere has learned about translation a little bit. Now, if it's vertical translation, instead of moving it to the side, we're going to be moving something up and down. Number 1, consider 3 linear functions. Why does it do that? Oh, it's back. I made it go darker, huh? Okay. You need it bigger? All right. Consider the 3 linear functions shown. G of x equals x, c of x equals x plus 3, and d of x equals x minus 3. Christopher? The first function is the basic function. The basic function is the simplest. Next to g of x, write the word basic. Oscar, did you write basic up here? 314. Basic because it's the simplest. In the case of g of x, it's the simplest linear function. It is in the form of ax plus b, where a is 1 and b is 0. You can write the given functions c of x and d of x in terms of the basic function. For example, if g of x equals x, you can substitute g of x for x in the equation below. So c of x is x plus 3. Well, those two are the same, so they substitute function notation where the x was because g of x equals x. Okay? Write the function d of x in terms of the basic function. So first of all, let's write d of x as shown at the top of the page. Now what they did here in this example for c of x is they replaced this with something. What are we going to replace that x with? Take a look. Here's the example. This expression is kind of a version or a cousin of our basic g of x equals x. What is this x? What can we put in there instead? What did they do last time? What's my finger pointing to? Is it too small? Is it too low? Make it a little bigger. Okay, right here, they took c of x equals x plus 3 and replaced the x with g of x. Why'd they do that? Those two are equal. If they are equal, we could substitute them. Okay? So right here, instead of x, this is going off the edge, I'm going to write d of x equals something minus 3. Instead of x, I'm going to write g of x. D of x equals g of x minus 3. So we had three functions that we were given at the beginning, one of whom was the basic, and two of which were a little more complicated. But because we know that g of x equals x, where x is in the other functions, we replaced. Describe the operation performed on the basic function g of x to result in each of the three equations, or each of the other equations. So for c of x, what did we do to g of x? How does c of x look compared to g of x? Here's c of x. It starts off exactly the same. G of x equals x. C of x equals x. What? Plus 3. Add 3. I'll make it smaller so I can fit that all in. And now for d of x, again, it starts out exactly like the basic function. G of x equals x. D of x equals x minus 3. So d of x, we need to minus 3. Okay, using the graphing calculator, graph each function within the bounds of minus 10, 10, minus 10, 10. Then sketch a graph of each function. All right, so let's go to our calculators. They gave us the window. That's what this bounds is for. These are the x values. These are the y values. We call this the domain. What is the range of x's? We call this the range. What is the top and bottom y's? Okay, so domain and range. We're given that. I'm going to start with on window. X min, they say to use negative 10. X max, they say to use positive 10. We'll leave it at scale 1. Y min minus 10. Y max positive 10. Change the scale back to 1. This is what they're telling us with these brackets. The range for the x's, the range for the y's. Are we good? Make sure I turn these guys on. Good. All right. Now we got to go to y equals, get rid of old functions. The first function we're going to put in is g of x. G of x equals x. Then I go down to y2. Who knows what I'm going to type next? X minus 3 or x plus 3. So x plus 3, and next function, third function, x minus 3. These are the three we're comparing to each other. You with me to there? Oh, let's push graph. Which one came in first? The middle. Okay, we need to sketch that. The middle came in first, and it is straight diagonal up the middle. That is g of x. Who remembers which came in next? The top came in a little bit higher, and that was my y2, and y2 was c of x, which is x plus 3. And then the last one is d of x. It's on the bottom, x minus 3. Oh, I didn't even draw it yet. Here it is. So you should have 3 lines. One went exactly through the middle. G of x equals x. Goes straight through the middle. C of x is a little bit above, and d of x is a little bit below. Now, my sketch isn't that great, but looking at the graphing calculator, how many up is this top line? I can see the little lines there. How many up is that? 3 up. Oh-ho! And how many down is the bottom line? 3 down. Compare the y-intercepts of c of x and d of x to the intercept of the basic function. Okay, so the basic function goes through the middle. So the y-intercept is 0. C of x, we said, is 3 higher, yes? So the y-intercept is 3. What's the y-intercept of the last function? Where does it go through the y-axis? Minus 3. Oh, so wait, what's happening here? I have 3 functions. They start out looking like this. That one, that one, that one. When I add 3 to whatever you have right here, what has happened to the line? It's moved, yes? Where did it move? Up 3. Next to this, at the very beginning, where we said basic, put up 3 next to c of x. Now, if the basic is that middle line going through y equals 0, and when I change that function a tiny bit by putting a minus 3, what has that done to the graph? Down 3. So this thing that we've added is making the vertical translation. It's making it move up and down. Guillermo, headphone out, please. Okay. Let's see what they're asking us to do now. Write the y values of each ordered pair for these given functions. Okay. Minus 2, minus 1, 0, 1, 2. I think we can do this in a table. All right. Let's see. Let's go table set. We already have the functions in y equals, so I'm going to go second, table set. And when I do a table set, I want to put in what are my x's going to be. So the lowest x I'm seeing there is minus 2. Where it says table start, I'm going to put negative 2. And these are going up by 1. So that's what we have already. Change table 1. Now table is over here, over above the graph feature. Second table. There we go. For this one, when x is minus 2, what is y? You see it in the y1 column for the table. Negative 2. And when x is minus 1, what do you see in the y1 column? Negative 1. When x is 0, 0. I'm working my way down. I'm looking at the x's, which is the first value in an ordered pair, and y1 is this function. Okay, so I've got 0, 1, and 2. What do you notice about the x's and y's before we move on? They're the same. Okay, now y2 is the c of x. That doesn't look right. Oh no, here we go. There we go. I see y2 over here. Maybe I'll put it on this side now. y2 is the c of x values. So at minus 2 for x, y2 equals 1. At minus 1 for x, y2 equals 2. 3, 4, 5. Let's see what y3 is. There we go. I used my cursor button, these arrows right here, and I found the y3 column. That's going to be the values right here, right here, right here, and right here. Minus 5. All right. Compare the table and the ordered pairs to the ordered pairs of the graph of the basic function. What do you notice? Okay, for example, let's start at the 0. That's probably the easiest compare. I've got 0 for g of x. What do I have for the y on c of x?
3.
Kenya, do you see a 3 right there where my finger is? Yeah, okay. How about over here? What is that? Negative 3. Okay, how about this? When x is 1 straight across. Here's the basic function. How does 4 compare to 1? How does 4 compare to 1? Something about 3. 3 what? It's 4. Is it bigger or smaller? 3 bigger. How does negative 2 compare to 1? 3 smaller. How about this? 3 bigger and 3 smaller. Okay? So y values are changing by the amount that was up 3 and the minus 3. Use the table to compare the ordered pairs, blah, blah, blah. What do you notice? C of x are all 3 bigger. D of x are all 3 smaller. Let's see. I'm going to double check how many of these sections. I think we might be going to 7. Oh, okay, write it down here. Oh, 1 through 10. We keep going. Transformation. Andy, could you read for us, please?
A transformation is the mapping or movement of all the points on a figure in a plane. According to a common operation, a vertical translation is the type of transformation that shifts the entire graph up or down. A vertical translation affects the y-coordinate of each one of the graphs.
Coordinate notation. Brody, could you read?
Coordinate notation is a notation that uses ordered pairs to describe a transformation in a coordinate plane. For example, you can use the coordinate notation shown to indicate vertical translation.
Okay, so if we have x and y, okay, and if we're translating vertically, we're going to be changing the y, either adding something or subtracting something. So we can show that in ordered pairs by x and then y plus b. b is a real number. Okay, so right here, if this is our function, all right, we're going to change this ordered pair. In the basic function, it's x and y. In this one, it's x, and then all of the y's are plus 3. In this one, for d of x, the x, we're still keeping the same. We're not shifting it left or right. But what happens to all of the y's? Minus 3. This is just a notation to show what's happening inside the ordered pairs for that translation. Flip page. Now let's consider exponential functions. Okay, here's your basic. What do we predict is going to happen here? How does s of x compare to h of x?
It's going to go up.
Which direction, up or down?
Up.
Up 3. What's going to happen here?
Down 3.
Down 3. The only thing that's changed is this little thing added or subtracted off the end. In this case, h of x 2 raised to the x is the basic function because it's the simplest. Write a function of s of x and t of x in terms of the basic function, then describe the operation performed. So s of x is exactly the same as h of x. It starts out exactly the same, but they've added 3. T of x, this one, starts out exactly the same as h of x, but they've minus 3. And we kind of already did what they were talking. This one's going to go up. This one's going to go down. Use a graphing calculator to graph them. Back to your y equals. We have the same domain and range, so we don't have to change the window. But y equals, I'm just going to clear everything so I remember to clear everything, and then go back up to y1, 2 raised to the x. I got to make that x an exponent. Down 2 raised to the x. And now I think I need to space over. Yeah, I had to use this button to get it out of the exponent. Now I'm going to go plus 3. 2 caret x. Space to the right, bless you. Then subtract 3. You guys got that in your y equals? How's it going, Kenya? You got those? Everybody over there?
How do you put how do you raise the x?
I use this little button. Some of the calculators you can see it up. Some of them you see the little caret and then the x next to it. So like the black calculators, it's very obvious. It makes it small and raises it higher. I think the gray ones, you see just the caret and the x after.
Yeah,
but this little button right underneath clear is what you need for making exponents. All right, so let's give it a try. Graph. There's the basic. Here's plus 3. And here comes minus 3. Just like before, basic's in the middle. Plus 3 is up. And minus 3 is down. Go ahead and try and sketch that in the box. Basic skims along the bottom, starts to curve up. It looks like it crosses at 1. 1, 2, 3, 4. That one. 1, 2. Starts here, coming in, curves up to cross at 4. And they go straight up. Okay. This one looks like it's crossing 2 down from the origin. So I'm going to mark that off to make my life easier. It comes in a little lower than that and curves up just in time to cross there. And then we see them kind of all meeting right at this edge. Remember last week we talked about how these things often have kind of an invisible boundary? You remember there's a fancy word for that. Yeah. Asymptote. Is there a P in there somewhere?
Yeah.
Asymptote. Okay. Right. It's an invisible boundary. We can see them kind of coming together there. Right. Compare the y-intercepts of the graphs. I was using the y-intercepts to help me graph them. Let's see, h of x, s of x, and t of x. Look at h of x. Where does it cross the y-axis? It's the middle graph. Look on your screen. Where's the middle graph crossing the y-axis? You can see little tick marks. Y-intercept 1. S of x. It's the top graph. Where is the y-intercept? Where does this graph cross the y-axis? Okay, so the top graph looks like it's crossing at what? Y equals 4. How about this graph? How far down is it?
2.
And so we'll call that minus 2. All right, so the y-intercept for the basic function is 1. This one's 3 higher. And then compared to 1, this one's 3 lower. All right. That's as far as my notes have us going for today. So, books can go away. You're starting on your homework packet.
I finished it.